Okay, good morning, everyone. Can you all listen to my voice?
Yes, sir.
Yes.
Okay.
Yes, sir.
Before I start the class, if you all have any troubles with the previous homework that I give you? No problem.
Number five.
Number two.
Sir, number 5.
Or number 3.
Okay, let me take a look first. Okay. Okay, in that case, stop share. Okay, number 3 and number 5. File first. Homework equilibrium first. Number 3, what is wrong with number 3?
I'm sorry, sir. Not number 3.
But number what? Which one? Which number?
Number 2, sir, I mean. Not
Oh,
number
you
3.
mean number 2. Okay.
Yes, sir.
Which part of it that you have a problem?
I have problem with the angle, sir.
Okay, so it's more to the geometrical problem then.
Yes.
Actually, it's not supposed to be that hard to find the angle. Okay. As you can see here, which angle that you have a problem with?
The theta one, sir.
Theta.
Yeah, the one in above O, above point O.
Yeah, what's the problem with that?
I have confusion counting that one, sir. I just find it confusing when I try to calculate it, sir.
Why you need to be confused? The small crane is mounted on the side of the bed pickup truck for the position of theta equal to 40 degrees. Determine the magnitude of the force support by the pin at O and pressure against it. What is this, Meryl?
I'm sorry, sir. I just don't understand the question that much, sir.
Okay, so you don't answer the question. So actually, the theta is 40 degrees.
Get confused, maybe, sir.
Yeah, the theta is actually 40 degrees, Meryl.
Oh, yes, sir.
The theta is 40 degrees, and what you're supposed to do, the problem is quite simple actually. The theta is 40 degrees. What you're supposed to do is to find out the force which is happening at CB, FCB. Okay. After you find out the FCB, okay, then you can convert it into pressure. Do you get it, Maria?
Yes, sir.
So basically, what you're supposed to find is just the FCB, the force which is happening at the link CB. Then after that, you have to convert it into the pressure. How to convert force into pressure? Actually, it's quite simple, right? FCB divided by the area, the cross-section area. How can you get the cross-section area? This one, 50 millimeter diameter piston. Okay, so the area is supposed to be P multiplied by a diameter square divided by 4, right?
Oh.
You get it?
Yes, sir.
So it's actually it's quite simple for number 2. Okay, now you don't have any problem here after I
Yeah.
explain it to you.
Yes, sir.
Okay. Number 4 is not supposed to be a problem, right? Number 5. Why there is a problem here? Anyone here having a problem here? Just now, somebody said that you are having a problem with number 5, right? Where's the problem with number 5? Hello?
I think it's just about it's lengthy to work in number 5.
Yeah, lengthy doesn't mean it has a problem, right? Risky, right?
Yeah, but actually, I have the question for number 3.
Number 3.
Yeah,
What's the problem?
I found the answer, but at first I sometimes confused where to put the wave force. At first I put it on B, but then I realized that I should put in the middle of AO.
Force.
The wake
AO.
force. The wake force.
The weight force, okay. When
Oh,
the 0.05 kilogram body is in the position shown, the linear spring is stretched 10 millimeters.
I think at C, sir, the weight should be.
Yeah,
Okay.
I don't know where should I put the weight, but in my homework I put it in the middle of A and O.
I think it should be in C.
It's up to you guys. You can put it here.
But I think
You
the
can
center
put
of
it
gravity
here.
in the
You can put it here. You can put it here. You can put it anywhere you want. But basically, you can see already. So you don't have to be arguing here, okay? It's supposed to be okay anywhere you want. You can put it as C like this, right? The weight, the weight force right there, the gravitational force. You can put it as C. You can put it at B, or you can put it in the middle between A and O. It's up to you. You can put it here as well, or you can put it here as well. It's okay. Or if you want to put it here as well, it's okay. As long as it's on this line of action, the result's supposed to be the same.
I see. Because we use the perpendicular distance, which will be 60 anywhere, right? Okay.
And anyway, when we talk about force, right? As long as it's in the its own line of action, right? You can move it anywhere you want. So you can put it here, 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 here. It's up to you, and the result will still be the same. Do you get it? Risky.
Yes, Pak.
So it's not supposed to be a problem, right? Okay then. Let's continue. Now, number 5. Who has problem with number 5? Risky as well, right? Or not?
No.
No, okay.
This
Risky?
me, sir.
Asep,
I don't know.
okay.
I can
Before that, right? Risky, do you find any zero force member here?
There is, sir.
Yes, if I remember.
Okay. How about you, Asep? Do you find zero force member as well, Asep?
At G, sir.
At G. G? Yeah.
Yeah.
G, zero force member.
yes, I also at BH as well.
BH. What else?
And then at CI.
CI. What else?
DF.
Yeah. That's all.
Oh, yeah, correct. Absolutely.
Okay, so the one that you want to ask is why you get 0 there, right, Asep?
Yes.
Okay, that's the topic of our study today.
Okay,
So,
looking forward.
So this is the things that I want to discuss. The next thing that I want to discuss is about zero force member. So wait a minute. start file. Where's my class? Okay, this one.
Can I ask for the more?
Yeah.
I'm a bit about number 2. I'm just a bit lost on how to draw the external forces. I was just lost from the start for now.
Number 2 on how to draw the what?
Like the external forces and the forces
External
affecting
forces.
each joint.
So basically, what you're
Just a bit
supposed to
confused.
okay then. The external forces that is supposed to be happening there, right? Let me go again. The external forces that is supposed to be happening there is just due to this one, and I'm not sure about the weight. There is no weight information there, so everything is based on this. Everything is based on that. So you can draw it just like this, simply like this. Just draw the AO, ACO beam, right?
Yes, sir.
You can just draw the ACO beam. So like this, like that. Okay. And at A, there will be an external force at A. 120 kilograms multiplied by G, right?
Yes.
Okay. Then beside that, what else that you have? There will be external forces at O, right? For Y, for X, correct or not? Because it's spin, remember? This one is a pin.
Oh yeah, because of the fin. Oh yeah.
Yeah. So you have to replace the pin, and you have to replace the pin with the horizontal and vertical force because it's two-dimensional case, right? Then beside that, there will be another external force, and remember, you can see this one as two force member, CP, because all the forces there only happening, CP, right? The forces there only happening at both ends, C and D, correct or not?
Yes, sir.
So it's two force member. When it's two force member, you can replace it with just a force like this. Yeah, like this.
The one on the point A, there's the only one affecting point A is only the weight.
Yes, of course, only the weight. So basically, this is the whole free body diagram.
Oh, okay. I'm a bit confused.
Yeah. In order for you to understand better, Aaron, okay, it is better for you to practice, keep practicing, right? By keep practicing, you will get more. How is it? You get used to it, and you know when a certain link is two force member or not a two force member, and how to replace a pin with a force, or how to replace the roller with a force, how to decide whether it's external forces or internal forces. You get it, Ira?
Yes.
Okay.
I also want to ask about what does the 110 millimeters apply to?
The 110 millimeters is actually the distance from here to here. Right? Of course, it is supposed to be there because it will affect, it will give additional moment, which is caused by FCB to point O, of course. Okay.
It's the distance from
This one.
point C to the AOB, or
yes, this one. That distance. You get it?
Horizontal distance then.
No, not horizontal distance.
Yeah.
So actually, it's like this.
From the C.
Yeah.
From
Whenever.
point C to the AOB.
Yeah, to the middle of the to the center line of the AO beam. Yes, correct. You get it?
Okay.
Yeah. So actually, this is for everyone here. Okay. If I have the two lines and I want to determine the I want to give information about the distance between these two lines. Okay, I can do it this way. For example, it's 10 centimeters or 10 millimeters. Okay, or I can just do it this way as well. 10 millimeters. Do you get it, Adam?
Yes, sir.
So you can do it this way, or you can do it this way. And for this particular things, we use the second one instead of the first one.
Oh,
Okay.
okay. Thank you, sir.
Yeah, no
Yes.
problem.
I-
Okay, then in that case, I think let's return back to the discard. Then let's return back to the previous discussion. Okay, just like what Azar want to ask just now. Okay, this is the thing is that we will discuss today. Zero force member. Okay, zero force member, and it is quite important as well because by knowing whether a certain member is zero force member or not, your calculation will be way shorter. So in the previous homework, if you know about this, you don't have to calculate as long as you don't have to calculate that much. Okay, from the beginning, you can determine whether some links are zero force like that, and you can skip the calculation for that particular links. Okay, so this is it. Okay, if two non-collinear members form a fast join. Okay, remember, two non-collinear members form a fast join, and no external load or support reaction is applied to the joint. Okay, the two members must be zero force member. Two non-collinear members form a fast joint, and no external load or support reaction is applied to the joint. The two members must be zero force member. I believe some of you bit confused about this explanation, but don't worry about it. Okay, this is the example. Can you find two non-collinear members which form a fast joint? Aser, because you were the one who asked me about the zero force member, can you please answer it to me? Answer it for me. Two non-collinear
Collinear
members
meaning-
forming a fast joint.
Let's see.
Only two. Okay, remember, only two members forming a fast joint. Can you find it out?
2 points that are non-collinear. That would be like C and
The trust joint, a trust joint, which is consists only two members, and those two members are not collinear to each other. Collinear means straight. You mean so like this?
or
This is
something like BENEC, sir?
Huh?
Like BENEC?
BENEC. No, that one is not only two collinear member, right? It consists of EC, EP, EP, and FE.
Also, like two trust joints that are not involved with each other. Is that what you mean?
Yeah. So actually, the one
Like
that
FB and DC, perhaps?
FB and BC,
And DC,
DC, and
FB.
F. No. One is like this. Can you see those two joints? Okay, those two joints, okay, consist of two members. For example, take a look at D, joint D. It consists of member DE and member CD. And those two members are non-collinear, right? They are not straight to each other. Collinear is like this. This is collinear. They are not straight to each other. Correct, Natasha? It's 90 is at certain degrees to each other, right? It's something like this, right? So these two join must be zero force member. The same as at joint A. At joint A, there is member AF and member AB, and those two are non-collinear, and only those two joining at joint A, right? So only two members joining at one particular joint, and those two are non-collinear. So that's one of the criteria of zero force member.
So
Do you get it,
collinear is
Asher?
basically two forces that form an angle. Is that what you're saying?
Collinear means like this.
Oh, the non-collinear one.
Non-collinear, yes, it means that it's not straight. So the joint, the link, the two links, right? This is one link. Sorry, this is one member, and this is the other member, but it's not straight. Like this, like this, like this, like this. It's non-collinear. If it's like
Also,
this,
something like
it's collinear.
perpendicular.
Not
Perpendicular is like
necessarily perpendicular.
as well.
Perpendicular is 90 degrees.
So, sir, so what you're saying is collinear is 180 degree.
Collinear is
Unless-
180
Yes,
degrees.
unless
Yes.
selain 180 degree, that is non-collinear. So like
Yes, non-collinear. But remember, the first criteria, okay? Two non-collinear member, only two member joining at particular joint. So that's why I give an example of joint B and joint A, because those two joints only have two members connecting on it, right?
Yes.
In that condition, you have to take a look whether the joint, whether the members which are connected to the joints, okay, are collinear or not. If it's collinear, then there is a possibility of non-zero member. But if it's non-collinear, which is like this, for example, or like this, okay, then those two must be zero force member. Okay, and remember again that there is no force that is applied on this particular joint as well. So if there is no force there, you can see it. There is no force. There is no force, and the joint only consists of two members. The joint only consists of two members, and both are non-collinear. Then
It is zero force
AF,
member.
yeah, correct. AF, AB, CD, DE, those four are zero force member. That's why we can.
I'm sorry, sir. Which one are the zero force members? The members that on joint A and on joint D. Yeah, I suppose.
Wait a minute. Let me do it again.
Sir, I have a question after this.
Wait. Let me.
Azhar.
Yeah. What?
After Azhar, I have a question.
I think I need to reopen the file first. So basically, those are zero force member. Okay. Then let me share again. Screen. Start now. Okay. So basically, just now, because those four are zero force member, then we can delete this member because it's zero member, so it's zero force member. So we don't have to analyze it in our analysis. That's why we can simplify this structure into this.
Sir, I have a question. Does zero force member actually means that they don't have any load, or they're just in equilibrium?
In that particular condition, okay, like this one, okay, the load there is zero, no load actually.
So it's unnecessary.
Not. Oh no. You cannot say it that way. Okay, only in this particular condition, Asar. Only in this particular condition, yes, it's unnecessary. But sometimes there is other condition where it is necessary for those member to be there. Do you get it? So later, when you have a design, then you analyze, okay, then it's zero force member, zero force member, zero force member. Then you delete all, and in reality, you didn't put it there. Okay, but in order for you to do so, you have to consider all the possible loading. Asar, do you get it, Asar?
Yes, sir. It's
because it will. Oh, it's sick. Okay, then. It will not be zero force member if I put a force like this. If I put a force like this, for example, F, like that, it will not be zero force member. AF and AB will not be zero force member if I put a force like that. And if I put a force like this, okay, ED and DC will not be zero force member.
Oh, okay, sir. I got it now. Thank you.
Okay. Just now, who else want to ask question?
Azhar, sir.
Okay.
I think I'm good, sir, because I already know that AF, AB, and ED and DC is zero force member. So if there is force, that will not become zero force members.
Yes, correct. If there is a force like this or like this, okay, those four members will not be zero force member anymore.
But what if the force is in the, like, not in the A joint but in the same member too? Like the force is not in the joint A, not on joint A, but on the body of the member.
In that case, it's not thrust anymore.
I'm sorry?
Remember, it's not thrust anymore. Remember, thrust consists of so thrust system consists of two force member only. Two force member, the force can only be given, okay, can only be given to both ends. It's either like this or like this.
Oh.
So if you have a member, okay, if you have a member which has this kind of force like that, and because of that, at the pin, there will be a reaction, for example, AX, AY, BX, BY, and F like this. This one is not zero force member anymore. Sorry, this one is not a two force member anymore.
Oh, I see. So only on the joints, yeah. The two force member, yeah.
So whenever we talk about thrust, it only consists of force member. Remember, so whenever we talk about thrust, it only consists of two force member. Okay? Yes, Asher?
So this is because in thrust it only works at the joints when.
Sorry, I cannot hear you clearly. Asher?
So it is because the forces on the thrust joint only works at the end, yes, sir. So if it's not in the same line, it cannot be regarded as a force being applied to a thrust joint. So that's why it becomes a zero force member.
Yes.
Is that so?
Yeah. It has connection with that, because for thrust system, for thrust structure, it only consists of two force members only, and two force member means it's either under tension or compression, and the force can only be applied at either end, okay, and it cannot be applied in the body of the member like that. And because of that, if we have a join with which only consists of two members, okay, and both are non-collinear, and there is no force, external force at the joint, okay, for sure, both members will be zero force member. Yes, that's correct. So the relation is like that.
I see.
Okay.
Thank you, sir.
About this zero force member, anyone else want to ask question?
Me, sir.
Yeah.
Back to number 5. That number 5 homework question. How can CI be H and D F can be 0?
That's the next level, William.
Oh,
Okay. So we will study about it step by step. Okay.
Okay, sir.
The next step is this one. Okay. The next step is this one, because just now we understand about this definition, right? But there is another definition. Okay. For this kind of thing, right? Let's take a look at this particular system, fast system. Okay, let's take a look at that particular fast system. And anyone here can see whether here we have a zero force member or not. And please inform me about the reason behind it. Anyone here?
Sir.
Yep.
For zero force member, does it have to be a joint atau pivot juga boleh?
Pivot or joint? No. Zero force member, it must be a member, not a joint. Member.
No. I mean, membernya kan out of two beams and joint, right?
That's only the first definition, Matthew. This one is the second definition. But before that, I want to ask it to you guys first, whether you can find the zero force member here or not.
Is it AD and AC, sir?
AD and AC. What's the reason behind that, Samuel? That's the next level. You did it correctly by finding the zero force member, but can you tell me the reason behind?
There's no force acting on it, on that joint.
There is no force acting on that joint. Yes, that's one of the reasons, but the main reason is not
that. Because the members are collinear.
The members are collinear.
I mean,
of course. ED and DC are collinear. But just now you are talking about this member, right? This and this, right?
Yeah.
AD and AC, you are talking about AD and AC being zero force member, but ED and DC are collinear. Yes, correct. But why AD there? Zero force member. When we talk about this particular joint. Sama. Hello, Sama.
Yes, sir.
You did it correctly by guessing that AD and AC zero force member, but you haven't explained to me why those two are zero force member. No idea?
Not really, sir.
Not really. Okay then.
Maybe non-collinear, sir. Maybe they are non-collinear, the AD and AC. And then there's no force that is acting. Yes, and there's no force acting on A. And maybe...
No. There is a force acting on A because there is a roller there. Right? So the reason is not because the joint A, but the reason behind it is when you take a look at joint D and joint C. Asal. That's the reason behind why AD and AC are both zero force member. Okay. Let me explain about it. why this kind of member can become zero force member. If we take a look at joint D, okay, if we take a look at joint D, and I assume that this direction is my X direction, and this direction is my Y direction. Okay.
Okay.
If we use sigma F Y equal to 0 at D, okay, at joint D, if we use sigma Fy equal to 0, okay, what forces that we have there? Only FAD, right? ED and DC are going to the X direction, right?
Only FAD.
So only AD is going to the Y direction. That's why you can see it must be 0, like it or not. Because if FAD is not 0 in this condition, okay, if FAD is not 0 in this condition, okay, the equilibrium at point B will not be there. It cannot be in equilibrium if FAD is not 0. That's why FAD is supposed to be 0. Yes.
Can you, Zeke, can you reiterate why it must be 0 again?
Because of this. Take a look at this. This is my X and Y direction. And now I'm looking at point D, 6.
Okay, yes.
Okay, and now I want to see the sigma Fy.
Okay.
Sigma Fy equal to 0 must be there.
Yes. Agree.
Okay. Sigma Fy equal to 0 must be there. And if I want to use sigma Fy equal to 0, I have to list out all the forces which is happening at the Y direction.
Yes.
At B, at point B. What are those?
Pardon, sir?
What are those forces which is going to the Y direction at B? Only this, right? Only FAD, right? Because FED and FDC are going to the X direction, right? 6.
Oh, yeah.
How about FAC, sir?
Huh?
Sir.
How about AC? Okay, AC. For AC, I have to take a look at C then. When I take a look at C, okay, let me use sigma Fy again equal to 0. Among those members who are joining at C, okay, please list out a member which has Y component. Who asked me about AC just now?
Oh, sorry. What did you say about the Y direction? Yeah. That was me.
Yeah. So now we take a look at C. Okay, sir.
Yes.
We keep using the same. Coordinate. X going there and Y going there. Okay, this one X, this one is Y. Now I want to use sigma Fy equal to 0 at point C. Help me to list out all the forces which is has Y direction at point C. Asha.
There are none actually. If I can see from here.
No, none. AC has Y component, of course, right?
Maybe
I'm talking Y component. I'm talking about Y component, not direct in the Y direction. The member is not necessarily have to be in the Y direction, but what I'm talking about when we talk about sigma Fy equal to 0, the member must we have to list out all the forces which has Y component, right? Correct or not, Asher? So this one, AC has a Y component, right?
Oh, yes, it does. Yes, it does.
Right? So FAC sin theta is the force in the Y component, right? Correct or not?
Correct.
Okay, FAC sim data is the F in the Y component, and it's only that at C, right?
Yes.
There is nothing else. That's why it must be equal to 0. Do you get it, Azar?
But FAC itself, it's not equal to
If
0.
FAC sim theta equal to 0, okay, if FAC sim theta equal to 0, can I do it this way? Azar, FAC sim theta equal to 0, both divided by sim theta.
Oh, itself is 0. Oh, I see.
You get it, Azar?
So it's also a zero force member then, right?
That's zero force member as well. So these two are zero force members. So you can delete both. Do you get it, Azar?
Okay, I understand now.
Yeah. If FAC sim data is equal to 0, sim data is not equal to 0, right? Then FAC is supposed to be 0 then, right?
Yes.
That's the thing, Azar. Okay. So FAC is 0 as well. So this is now the second definition. The second definition, if we have a member, if we have a joint which consists of three members, okay, which consists of three members, and at that joint, two members are collinear. Only two members are collinear. The other one is not collinear. The non-collinear member, this one, the non-collinear member will be zero force member. This is what happening at joint B and joint C. ED and CE are collinear, but AD are non-collinear, right? The only non-collinear member there is AD. AD will be zero force member. The same as joint C. CD and BC are collinear, but AC is non-collinear at that particular joint. That's why AC will be zero force member. And remember, those are only applied when there are no external forces happening at joint D and joint C. If there is an external forces like this, for example, AC will be non-zero member. The same as this. If there is an external force like this at point B, then AD will be non-zero member as well. Do you get it, guys? So basically, if you want to simplify it, we can simplify it like this. Matthew, do you understand, Matthew?
Yes, sir. I just wanted to ask if this is the different kind of zero force member.
Yes, this is the second kind. The first kind of zero force member is the this one. So this is the first definition of zero force member. This is the first kind of zero force member, and this is the second kind of zero force member. It's slightly different, not slightly different. It's completely different. So we have two kinds of zero force member. Do you get it, Matthew?
Yes, sir. I'd like to ask.
Yeah, Matthew first. Yep.
The first one, first slide.
The first kind. Okay. This one.
So here it is seen that D is a joint, right? D here is a joint.
Yes, correct.
What if can we, if D is not a joint like a pivot, can we assume DE and DC is zero force member also, or you cannot?
Pivot is just the same as joint, right?
Pivot as in yang ada rolling pin atau the fixed pin.
Ah, you mean like that? Oh, you mean something like this? You mean?
Yeah.
Oh, of course, something like that. It's not. You cannot put it as zero force member. So for things like this, right? Fe and Fb, okay, it's not zero force member because if it's pin joint at F there will be external forces, right?
Oh,
There will be
normal force.
Fx and there will be Fx and Fy, right? Because of pin joint there. Correct or not? The same as
Yes.
a roller joint like this. If only two members are joining at that particular joint as well, those two members will not be zero force because roller will give external force, the vertical force. Do you get it, Matty?
Yeah, I get it now. So
it is
it has to be a
only
joint.
applied on the free joint,
Okay.
not join at the pin or join at the roller like that. Free joint, only free joint.
It'll be
Free
zero,
there.
yeah.
Yeah.
Because I was thinking like for point D to be at equilibrium, ED must have force to D and DC must have force to C. Is that not possible?
No. If it's zero force member, then ED will not give any force to point E, and DC will not give any force to point C. So basically, if from one particular joint, a member is already determined as a zero force member, then what you're supposed to do is just to delete that. That's all, because it will not give an effect to the other joint as well. That's why we can simplify this particular problem into this one. Okay, because for example, CD at D, because of joint D, we consider CD as zero force member. Then at joint C, there will be no effect of FCD. FCD will be zero. So that's why what we're supposed to do is to just delete that. Do you get it, Ned?
Yeah, sir. Thank you.
Good. Who else here want to ask questions, just
I think it's risky.
Yeah, Rizky?
The one I want to ask is the second type of zero force member. I still don't really get what's the I still don't really get what the requirement at the second type.
Oh, the requirement is like this. To make it simple, okay. To make it simple, we have a joint. We have a free joint. Okay. We have a free joint which is consists of three members. Okay, three members, and two members there are collinear, and the other member are non-collinear. The non-collinear member will be zero force. That's simple. Okay, free joint.
But
three members.
If like that, so the ADC, it's depend on which point we observe. Like if we observe
yes, of
point
course.
D.
Yep, correct. It's correct. If you observe point D, then AD will be zero force. If you observe point C, then AC will be zero force. But if you observe point A, you cannot determine that. But if from just one joint you can observe that a particular member is zero force, then delay that. You don't have to consider the other point. Do you get it, Christy? It must be zero force.
Okay, Pak.
Okay. Now, in order to make it simple, we can try to reanalyze our homework with the same analysis. Okay. Can we find the first type of zero force member here?
BH.
No, first type. We have two types, right? First type and second type. Just now. The first type first. first type of zero force member where two non-collinear, only two non-collinear members are joining at one free join. Is there any kind of a member like that? Yeah.
Is it GB and GD, sir?
GB and GD. No, it's 4 members joining at GN.
Oh, okay. Only
it's not two
is
it's
allowed.
not two members.
Okay.
Right? Only the first type.
I think it's
it must be only 2 members. Huh? Sorry, Rizky? Yeah, Rizky. The first type, not the second type. The first type first. Hello, Rizky. That seems like connection problem. Anyone here can guess whether we have a first type of zero force member? Matthew, can you find a first type zero force member here?
Hello, Pak.
Is it like BH and BG, sir?
Who?
BH and BG.
BH and B.
Oh no, sorry, HG I meant. Sorry, BH and HG.
BH and HG. No, of course, HG is H there is a 3-member join, right? The first type of zero force member is supposed to be 2-member join. Yep, Rizky.
I don't know if it's wrong or not, but is it E because E is a roller, then there's no external force, but I don't know.
I told Matthew before, right? Risky. Whenever there is a roller, it's considered as a non-free join because roller must be roller or join. Roller or pin must give the external force. Roller can give a vertical force, right? Yep. So basically, actually, there is no first type of zero force member. No member there, which is considered as first type zero force member. No. But there are a lot of second type zero force member here. Okay, the first thing, this one. Due to join H here, BH is zero force member. Due to join F, DF is zero force member. Due to join I, CI is zero force member. And I believe, based on your calculation, you can find that BH, CI, and DF are equal to 0. If it's not like this, then your calculation is wrong. Your calculation in your homework is wrong. Try to recheck again. These 3 must be 0. Correct or not? Matthew, can you recheck your homework for me?
Sure.
Okay, Samuel. Seems like you want to talk. You want to say something? Yes, Samuel.
It's correct.
These 3 zeros, Samuel.
Yeah.
Must be. So Rizky, just now you told me at the beginning of the class, you told me this particular homework is doable, but the calculation is wrong, right? It will be way shorter if you know from the beginning. Correct now, Rizky.
Also, we have to go around by eliminating the zero force members first.
Yes, correct. Yes. So basically, our problem now becoming like this. Okay, this one. This will be the simplified one. Okay, like this. Then there will be pin joint here. There will be a roller here. And don't forget to put the force, of course. The force is supposed to be there as well. 30 kilonewton, 17 kilonewton, and 24 kilonewton. So now the problem becoming like this. Okay. So now the number of joint that you're supposed to solve is way less than before. You don't have to solve for joint H. You don't have to solve for joint I. You don't have to solve for joint F. So you eliminate 3 joint calculation there. Do you get it, guys? So whenever you have a trust structure, trust problem, what you're supposed to do at the beginning is to try to simplify the case. How? By trying to take a look at zero force member, either the first type or the second type. After you do so, then you can start analyzing. Yes, just now, who want to ask question?
Yes, sir. So in future homeworks and in the midterm test, can we just state like this, or do we still
yes,
have
of course.
Okay.
Yes,
so we
of
don't
course.
have to show our work.
What you're supposed to do at the beginning is mention the zero force member. Okay, remember this, and this are zero force member because of what? Okay, and after that, start the analysis.
Okay, sir.
Okay.
Thank you.
The basic concept in statics and later mechanics of materials is, if you can make it simple, why not? Don't put yourself in the harder position. Okay. If you can make it simpler, why not? If you can solve it in 10 minutes, why you have to finish everything in 30 minutes? Okay, Rizky?
Yes, Pak.
Yeah. Anyone have any problem here? If you still have
sir,
any problem, you can ask me. Yes, Azad, yes.
You say that two force member needs two member that is non-collinear, right? Yeah.
Which one? Which one?
If in H. Oh no. The homework one, sir. The homework one. I'm still a little bit confused. Why the BH, the CI, and the DF? Because you say before that you need two non-collinear members, right? So there need to be two members that cancel out like that.
That's the first type of zero force member. This one.
Oh.
That's the first type of zero force member. Just now I explained about the second type. Right? This is the second type of zero force member. So here, PH, CI, and DF are considered as the second type of zero force member. Okay, sir? You understand why about this way? Just now I explained quite long about this, the second type of zero force member. Why here AD and AC are zero force member. Okay? Try to rewatch my video later, okay?
Okay, okay. Okay, sir.
Okay, Rizky, yes?
If I do it from point A and I got FAB and FAH, and after that I look at point C and I suggest that FBC is the same as FAB and CD is the same as FDE. In the point C, if I menjabarkan gayanya, saya mendapat I got the force of FCI. Is that correct or not?
No. You did it wrongly. Okay. So it's like this. Your previous homework, okay, I haven't explained about zero force member. I did it, I purposely did that in order for you to know, oh, why this in order for you to question yourself why this member are zero force member. Your calculation just now is a little bit wrong, William. Okay, so the first thing that you're supposed to do in order to solve this problem without knowing that PHCI and DF is zero force member, okay, you have to solve for AX, AY, and CY first. Then after you solving for that, okay, so how can we find out AX, AY, and EY? Okay, we can consider the things as one free body diagram, right?
Yeah, yes, sir.
Then we can solve for AY, AX, and EY based on the external forces that we have there. After solving for AX, AY, and EY, then you can solve for joint A or joint E, which one that you want to start first. It's up to you. Okay, if you solve for joint E, then you can find for AB and AH. Okay, then if you want to solve for point B, there is no way for you to solve for point B because the number of unknowns there are too many. So what you can solve for next is point H. William.
Yes, sir.
Okay, you cannot go directly here, William. No, you can't. But if from the beginning you know that these three members are zero force member, then you can start from the top, point C here, without knowing AX, AY, and EY. Because here we have two unknowns only, so we can solve that.
Okay, sir. Thank you.
You get it?
Yes, I get it, sir.
Yeah, but after that, still we have a problem. So, like it or not, we have to solve for AX, AY, and EY. Okay, so basically, in a joint method, we have to try to find the joint where only have two unknowns. We cannot solve for more than two unknowns because we only have sigma Fy equal to 0 and sigma Fx equal to 0. We don't have more than, we don't have sigma moment because it's joint. Do you get it?
Yes, sir.
Okay. I will return back to Rizky. Rizky. Hello, Rizky. Where are you, Rizky?
Lagi BAB, Pak.
Ash. Yeah, anyway. Who else here? Fasadiara.
Yes, sir.
Do you understand my explanation before? Fasa?
Oh, yeah, I understand.
Rookie, yes, you can go. Don't worry about it. Okay. So now, because you understand the previous explanation, now if I ask you, Fasa, to solve for this particular problem, can you find for zero force member here, Fasa? Can anyone here find zero first member in this particular problem? Please help Fasa to answer my question before. No. Oh yes, Fasa.
I cannot find any.
Yes, of course you cannot find because there is no zero first member here.
Oh, yeah.
Okay, so there is no zero force member. If there is no zero force member, then what are you supposed to do in order for you to solve for this problem, Pastor? Where will you start, Pastor?
I think lihat semua joinnya. Okay.
Starting from
G.
G, correct? Because we only have two unknowns that can be solved, right?
Yeah.
Yeah. So from join G, we will be able. Okay, from join G, we will be able to solve for this and this. Correct, right, Pastor? GH and GF. Okay. After solving GH and GF, then where we supposed to go? Which join are you supposed to analyze? Next.
If my guess is if it's not HF.
Nah, but if we go to F, the unknowns there are still 3, right?
Oh yeah.
So the only option is
H.
H, correct? Going to H because there we only have 2 unknowns, so we can solve for it. We can solve for HI, we can solve for FH, right?
Yeah.
Then after that,
F.
F, right? F, solving for this and this. Then after that, going for I, solving for this and this. Then E, this. Then G, this and this. Then D, this and this. Okay. Then K, we can solve for this and this. Then C, this and this. How many calculation there? How many joins there that we're supposed to do in order to solve for these 3? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 joins, meaning 18 equation, right? Because every joint we have 2 equations, right? Correct, Masa?
Yeah.
So in order to solve for KL, CL, and CP, we have to solve for 18 equations, which is a lot, right? Okay. Do you want to solve it in simpler way, Masa? Because the one that we need only KL, CL, and CP, right? We don't need the other member.
I don't know.
No, but I mean, if I give you an option to solve this particular problem only with 3 equations, which one that you will choose? 3 equation or 18 equation?
3 equation.
3 equation, why? Because it's much simpler, right?
Yeah.
So there is one huge disadvantage. Okay, thank you, Faza. Okay, so there is one huge disadvantage of using join method. Okay, if we have to solve for all the members, yes, join method will be advantageous for us. But if we just need to solve for certain members, for example, in this particular problem, we are only asked to find stress at the load at member KL, CL, and CP. Okay, so only 3 members. We do not need the other members. Okay, we do not need to solve the other member. That's why in this particular case, the join method is disadvantageous because we have to solve for 18 equation in order to find for the 3 members that we want to find for. Okay, that's why it's come to the second method. The first method is the one that you already mastered. Okay, the first method is join method. The second method is section method. This is the one that I will teach you in the remaining 15 minutes, 15 to 20 minutes. Rizky, have you written to my class, Rizky?
Yes, Pak.
Okay.
Sorry.
Yeah, no, it's great. But did you follow my explanation too fast?
I just got back when you have point all the joins, so I really don't.
Yeah. So basically in this particular problem, we have to find for we only need to find the load at member KL, CL, and CB, right? Risky. But
yes,
using join method, we have to solve for 18 equation because we have to solve for join G, H, F, I, E, G, D, K, C, like that. Total 9 joins and in total 18 equations. Just in order to find 3 members, the load at 3 members. Okay.
Okay.
And previously you complained to me that the calculation is long. Right, Rizky? In the previous homework number 5, you complained to me that the calculation is long. Yeah. So if we have to only find certain member in our calculation, then join method is not advantageous for us. So we have to use the other method, section method. This is the thing that I want to teach you guys after this. Okay. In join method, we have to solve it one by one. Okay, we have to solve it one by one. All joins, we have to solve it one by one. But in section method, we can just cut it. Okay, we can just cut it. But of course, in the section method, the cutted part, before you do the cutting, you have to remember to find out the external forces that we need to use. Okay, after you find out the external forces due to the roller or due to the pin, like that. Okay, and due to the other external forces, then you can do the cutting. Okay, but remember, when you do the cutting, okay, you have to cut maximum only 3 members. Why 3 members? Because we only have 3 equations. Okay, we only have 3 equations. So basically, actually you don't have to cut only 3 members, but when you cut, okay, you have to remember that the number of equations that we have, okay, is only 3 per free body diagram. So the number of members that you can cut is actually depend on that. So it's not necessarily have to be 3 members. Okay, for example, if we have something like this, I want to solve it using a section method, then I will cut it here. Okay, my cutting line will cut member EF, member BE, and member BC. Okay, then those cutted members, I have to replace those with external forces. So later, I will have 2. Okay, I will have 2 free body diagrams. The first free body diagram will be like this. Okay, so this is the first free-body diagram. So basically, the first free-body diagram is the left cut. From the right cut, I can draw second free-body diagram. Okay, from the right cut, so this is the first free-body diagram. This is the second free-body diagram. From the second cut, I can draw the from the right cut, I can draw the second free-body diagram. It will be like this. Yeah. R2. Then what else there? Because I assume everything, all the cutted members as a tension member. Then here I have to assume the same. FE, FBE, then FBC. Something like that. So this is the second method, section method. We cut at the members that we want to find out. Okay, but you have to be very careful. Why you're supposed to be very careful is because the number of equations that we have is limited. 3 per free-body diagram. So from here, from the first free-body diagram, we will be able to get 3 equations. And from the second free-body diagram, we will be able to get another 3 equations. Okay. Do you get it, Rizky?
I think I got the basic concept.
How about you, Fasa? Fasa Diara?
Yes, sir.
Do you get it, Fasa?
I'm still trying to understand.
Okay then. In order to make it faster for you to understand,
hello, sir.
who's this, Jovan? Okay.
I have a question, sir. Can you go back to the previous slide?
Wait. Let me. Yeah. I need to clear out some of the explanation before. The previous slide, you mean which slide? This one? Or this one?
This one, the section method.
Yes.
So in section method, should we divide it symmetrically?
Not necessarily, Jovan. That's why I want to give an example on this particular problem, Jovan. Just now, remember what? When I discussed it with Fasa Diara just now, in order to find out these 3 forces at those 3 members, okay, we need to use 18 equation, right, Jovan?
Yes, sir.
Okay, now, if I ask you to cut it here, okay, to make a section there, by doing so, we can solve it just only with 3 equations. Let me show you the resulting free-body diagram. The resulting free-body diagram will be like this. Okay, Jovan, do you get it, Jovan?
Yes, sir. Yes, I get it.
And we can solve this by using sigma fx equal to 0, sigma fy equal to 0, sigma moment equal to 0, actually by applying the whole equilibrium equation for this particular free body diagram. Do you get it, Jovan?
Because before the KC, so HI, IJ, it's all the same, right? The force.
Sorry. The force where?
You can cut it in KL, in the middle of KL. Because
KC.
in HI, IJ, it's all the same, right? The force.
HI, IJ,
JK.
No.
It's all the,
there is no relation with that. I cut it here because this is the things that we want to find. KL, CL, and CB.
So if, for
KL
example,
is this, CL is this, CB is that. Because by cutting here, I will
cancel out ya, Pak.
Sorry?
By cutting all the force moment and will be cancelled out because they have opposite direction like KL and LK. They will cancel.
No. Yeah, actually, that's one thing to say it, or the more correct thing to say it is all the forces happening inside of the cutting part here, okay, will be considered as internal force. This key.
I see what.
Because it's actually belongs to the member HI, right? IJ, JK, DK, etc. But when we cut it like this and we consider this part as one system, okay, the one that I make it as fat here as one system, then everything inside of that will become internal force. The external force there will be just this one, 200 kilonewton, and FBC, FCL, and FKL. That's why I can solve for FKL, CL, and BC by doing so. Do you get it, Rizky?
Yes, Pak, I got it now.
Do you get it, Jovan?
I get it, sir. Thank you.
Sir?
Yep. Yeah, madam?
So if we make it like this, like we ignore the lines inside, so
yes, of course we
just
ignore it because everything become internal forces. So we just need the external forces only. Now KL, CL, and BC become our external forces.
Oh, okay, sir.
Because we cut that member and it become external forces, right? We replace the member with the external forces. You get me?
Yes, sir.
So this is one of the techniques that we can do to solve this kind of problem. Okay, it's quite interesting. So previously you have to solve for 18 equations. Now you can only you can solve it using just 3 equations. Okay, so that's the basic thing that you're supposed to know about cutting, right? After you cut, yes, this is the calculation. CL, CB, and KL. But by doing calculation like this, it will become more confusing for you. So it is better to just use the free body diagram here that I draw it for you, because all the dimension will be clear there. Okay, just use this. Use sigma fx, sigma fi, and sigma moment in order to find out for FBC, FCL, and FKL. 3 equations, 3 unknowns. I believe you will be able to solve it. Correct, right, Rizky? You will be able to solve this. Right?
Yes, right, Pak.
You prefer this or solving 18 equations, Rizky?
Pardon me?
You prefer to solve, you prefer this kind of method or solving 18 equations using join method?
I think make it one system like this is faster and simpler.
It's way faster, yes. Okay. Now, this is the last thing that we're supposed to solve today. Help me to solve for member PC, PE, and EF. We only need to find the forces at member PC, PE, and EF. Can you help me? How should I cut this? Meryl, can you help me? How should I cut this, Meryl?
Yes, sir.
How should I cut this?
Between AD, sir.
AD?
AG.
AG.
And we cut horizontally, can we?
Nah, we need to find out for this. This one, this three. Why we need to remember, try to cut as best as you can at the member where you want to find the force. The same as this one, right? This one, okay, we want to find out for KL, CL, and CP. That's why I cut it this way.
So we cut in the part where we need to look for the forces.
Yes, of course, because later it becomes the external forces, right? And the external forces that we can solve, right, Meryl?
Yes, sir.
So now the cutting is like what?
The cutting is
vertically, right?
Yeah, vertically between B and C.
Yeah, just do it like that. Cutting, just doing the cutting like that. And now our free body diagram that we need to solve is become like this. This is 14 kilonewton. Okay. This is point D, C, and E. And F, E, E, F, B, E, and B, C become external force. Correct, right, Miriam?
Yes, sir.
Okay, I assume, sorry, my drawing is a bit off. Okay, then I will redraw again. The problem with this is this cut. Okay, let's do it again. Okay, we got it here, and then we draw it like this. Okay, 14 kilonewton. Then we have T, E, C. Then we have FBC here as external force. Then we have FEF as external force. Then we have this as well as external force, FBE as external force. So this is the free body diagram that we need to solve now. How to solve it? Using sigma Fx equal to 0, sigma Fy equal to 0, and sigma moment equal to 0. Can we solve this matter? Hello,
yes, sir. Yes, sir.
Yeah, we can solve this. 3 equation, 3 nanos. So we can solve this. So actually, that's all the things that I need to explain to you guys today. This is the section method. And tomorrow, I will give you some problem example on the trust. Okay, on the trust, and maybe at the end of tomorrow, okay, there will be quiz. Okay, so please study your hard. Please study hard. Please study the hardest on the section method and the join methods. Okay, so for tomorrow we will concentrate on finishing the trust. Okay, guys. So if you have any problem in the trust, either it's a section method or a join method, you can ask me tomorrow. Okay. I think that's all for today. Thank you for listening. See you guys tomorrow.
Thank you, sir.
See you.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.